Okay, hi all. Thank you for coming. My name is Mario Fusco. I work for IBM. I mostly work on the Launch4j project these days. But to do something different, I'm not here to speak about AI or agents this morning. And I'm hoping, this is a good way to sort of conclude this week in a different and lighter way, I hope. So I hope this is a good talk for a Friday morning after a so busy week. Okay, so today I'm speaking about what I call behavioral software engineering. The name can be a little bit misleading, but if you know something about behavioral economics, which is the things or which I'm speaking about today, probably it could make sense, or I hope it will make sense at the end of the talk. So let's go. So funny, stupid, short story. Two economists are walking down the streets, and one of them says, "Look, there's a $20 bill on the sidewalk," and the other economist say, "No, there's not. If there was, someone would have picked it up already. It's impossible that that $20 bill is on the sidewalk." Okay, so I understand this may sound a stupid joke, but in reality, this is the essence of the efficient market hypothesis. So according to this hypothesis, which is mainstream in economic, or it was for a long time, there are no free lunches, right? It's impossible that the $20 bills is on the sidewalks because there cannot be free lunches, because share prices reflects all available information at the moment, and it's impossible to beat the market. And this is because the markets are totally rational, and all investors are unbiased, and the money is fungible. So these are all the hypotheses that are at the basis of this efficient market thing that has been, the theory started immediately after the great crisis of the 29, but in reality it has been better formalized by Professor Eugene Fama of the School of Chicago during the 60s. But what happens like 1 decade later is that these other two guys started to debate, to say that, okay, this is the hypothesis of the efficient market under the hypothesis that everybody take decisions in the most rational way, but this is not normally how human works, a human think. So we, in reality, have lots of cognitive biases that affect our decision, and this affects our decision in the economic field. But as I said, I want to take lesson from the biases that they found during their decades-long research in the economic field, but translate them in our software engineering world. So, in essence, the human being of Eugene Fama was this Econ, which is totally rational. It never makes mistakes. It is never biased. It doesn't have emotion, basically. And we know we are not like that. Okay, we are not like that while we are taking decision, even important decision. And in our day-to-day work, we take decision, big and small decision, every day and every moment. And I feel myself closer to Homer than to Dr. Spock, honestly. Okay, and the fact is that we don't reason in a perfect, unbiased way because we are full of bias. But this bias have a common thing. There are tons of different biases, but the fact is that, okay, we have personal biases that are our personal point of view, But the biases I'm speaking about today are systematic mistakes of judgment that we as human beings do, and we do all in the same way. I mean, for these biases, we don't do mistakes in different direction. For how our brain is wired, and for a good reason, as we will see, we do mistakes all in the same direction. We do all the same mistakes. And if you want to know more about behavioral economics, I can suggest you these books, but there are many other. I especially loved this one, so that's why I'm suggesting them. Okay, so let's try to go through these biases, both introducing them under an economic point of view and then trying to figure out how they affect our day-to-day job as software engineers. The first one that comes me to mind is patternicity. Okay, so this is quite common. Our brain is wired to find meaningful pattern also in meaningless noise. Okay, this is a quite famous pictures of the surface of Mars. I don't know if you ever seen this, and you can't avoid seeing a face in this thing. And of course, you rationally know that there cannot be any face. It's the surface of Mars. But we can't help to find a pattern in this. So this thing has a more scientific name than patternicity. It's called apophenia, which is the tendency to perceive meaningful connection between unrelated things or random data. Okay, our brain cannot accept that the two things that seems related in reality they aren't, or our brain cannot accept randomicity in some way. It believes that there has to be a meaning in everything. That's the problem. And if you look for financial advices, you often find stuff like this that to me are totally crazy if I think in a rational way, but people really believe in this stuff. So they see a pattern in the stock market. These guys say that before lunchtime the market goes down for some reason, and then it disinvests, and then after lunch it put money on the low, and then it take profit up until the end of the market day. And of course, if it was so simple, everybody would be rich, right? So it cannot be like this. But this guy's he found a pattern, or he found something in this graph and decided that take the decision about this eventual pattern that he thinks he discovered. Okay, and again, if you look for this stuff on internet, you find ton of stuff like this, and in reality, maybe many of you knows this website, which is about spurious correlation, meaning that if you take two random values, it's likely that you will find random values that seems to be correlated, statistically correlated, but of course, there is no actual relationship between, I don't know, the number of movies made by Johnny Depp and seasons wins of the Los Angeles Chargers. Right? There cannot be a real causation effect between these two quantities, but there is a correlation. But this is just to demonstrate that correlation in many, many cases does imply causation. And of course, as I said, I find patternicity often also in our work. We tend to find pattern, or for instance, in many cases, we believe in stuff. Okay, we have gut feeling. You know, do you have gut feeling at work? Right? We have gut feeling. We believe that a bug is there, even in a place that is totally unrelated. It's just a coincidence, but we believe that a random change caused a bug at somewhere else. Or even worse, we know things, right? We know that in Java reflection is bad. So we know that if in this particular point of the code, if we remove the reflection, the code will be faster, okay? But in reality, you are making a big effort in that point, and that point is hit probably only one time during the program execution. So you are really, in practice, not changing everything, but we know things. And this causes a sort of placebo effect, right? We remove the reflection in that place, and then without measuring anything at that point, we are happy with ourselves because we achieved that result, even without measuring the actual outcome. And we believe that this will have a good effect on our stuff. It's really a placebo. And before starting working, in reality, I still do it a lot of this now. I do lots of performance engineering, try to do performance optimization, trying to help the Quarkus team in this instance. So, and in the field of benchmarking and performance optimization, I see a lot of patternicity. So sometimes, again, you change something, you have a random improvement, and you tend to believe that the random improvement is a general system improvement while it's not. Or what happens really, really often, and this is our fault, to be honest, is that we have a specific benchmark, and we do benchmarking, but my friend Francesco Nigro called this in this instance benchmarketing, because we are not making our program faster against that benchmark because it will be better for user, but it will be only because it will be showed up in the benchmark list. So we are doing something on our program just to make that benchmark happy, not to make the user happy. And regarding benchmark, it also happens often that we test isolated piece of code, but when we do this, we do micro benchmarking, for example, but while doing this, we fail to see the whole picture, how this affects the entire system. And also we assume that by our synthetic benchmark will mimic what happens in production, while often this doesn't happen. So again, there are lots of patterns that we try to recognize while doing benchmark that are also not true. And the last thing is probably the most important one. This happened to me a lot, okay? I do something, I spend 3 days trying to make a piece of code faster, then I run the benchmark, and I'm happy because the benchmark was 3% faster. And this is another placebo effect, right? Because normally probably that benchmark has a plus minus 5% variance, and I'm making this 3% faster in one single run. So basically, this is just noise. I'm not measuring anything, but I'm making, I'm patting myself on my shoulder because I achieved some sort of result. And in essence, yes, I'm speaking about data, and benchmarking is also, it's a lot about data, but in reality, if you torture your data enough, you can make them confess anything. And about this, there is also an effect of overfitting. If you recognize a false pattern, that then you overfit your work against that pattern to make, for instance, that benchmark better. But we just found a matrix, and we are doing our work to improve only that metric, not to improve the actual outcome. And this is also known in literature as the Cobra effect. I don't know if you ever heard about this, but what happened is that in the 50s there was an overpopulation of cobra in India, and then the UK government decided to reward people for killing cobra, and what happened at the end is that they start breeding cobra just to kill them, bring them to the UK government and take money. So if you set a false measure, a false target, then people will start overfitting their work with that target. And of course, yes, this creates perverse incentives. So if your goal is fixing as many bugs as possible, but oops, you created all of those bugs. So I don't know if it's a good metrics enough, or a few years ago, a good metrics one was how many lines of code you have produced in a given working day. It was even crazier. So if we create a metric and we adapt our work to make that metric happy, hit that metric, but without missing the full picture, then the result is not that good. That's the thing. Okay, and well, the first way to prevent patternicity, for instance, in the benchmark field is, of course, always measure what you do, take count of the noise, be skeptical, never forget that correlation is not causation, of course, encourage peer review, and be mindful of the confirmation bias, which is the thing that I said before. I want something that confirmed that my program goes faster after my fix, and it was 3% faster regardless of the noise, and I was happy about this, okay? And probably the most important thing is the last one. Embrace a culture when it's allowed to say I don't know, because I don't know open a doubt, and the consequence is, okay, I don't know this thing, but I can learn, I can figure out how it works. If you think that you know, then you will never learn, okay? Or more in general, I always say that the first step to solve a problem is admitting that you have a problem. This is exactly the same thing. Another interesting effect is the anchoring effect, and probably we all suffer of this when we go shopping, for instance. If you see a car that is priced 30K, you believe it's too expensive, but if you see a price tag with the 60K and then the 30K one, then you immediately think that this is a great deal. Why? Because our brain takes an anchor, which is the 60K tag, and then we adjust from the anchor, but this adjustment is always insufficient. So that's why it's called the anchoring effect. We are anchored to the first number that we will see. And the Kahneman and Tversky found this effect in a very famous experiment in the 74. They let people to go spinning a wheel fortune, and then they asked people to estimate a percentage between 0 and 100, the percentage of African countries in the UN. So, of course, the two numbers are totally unrelated, right? But still, they measured an anchoring effect between the number that came out of the Wheel of Fortune and the responses of the tested user against this question that, of course, is totally unrelated. So the lesson here is that wherever there is a number, you will anchor to it, regardless if it's meaningful or not. Okay, and this affects also how we judge our stuff. For instance, this affects how we judge bug severity. So if a first person finds a bug, and usually the first person that finds a bug always tag it as critical, super high priority, and then you are anchored to the judgment, but probably it's a trivial thing, but you are still anchored to the first person who gave a look at it. And you have a lot of example like this, like code. You are anchored to old way of doing things also, but we will see this in we'll speak about habits and some advice effect later. And of course, once again, I'm bound to this benchmarking field, and you see a lot of this anchoring effect while doing benchmarking. Once again, you try to fix your code, to not fix, but make it faster. And you find a 10% improvement, and you are super happy, and you think you are good enough. Why? Because you are anchored to the first result. But probably you obtain a 10% improvement, and it could be twice as faster or thrice as faster, and you don't know. But you are happy with the result because you are anchored with the old value. And a few suggestions also to limit this thing is to make independent decision, delay exposures to other opinions. So you ask, for instance, your colleagues to judge the severity of a bug, but they have to do this independently, not knowing of the work of each other, because only in this way you can avoid anchoring in a very first instance the idea of one developer to the other and make them influence each other. And you can rotate roles of your teammates. Another two things that works quite good to mitigate this problem is that if you set a single value, you will be anchored to it. But if you set a range as big as possible, then it will give you more possibility, more flexibility to move inside that range. And then also use historical data to have a good idea if the anchor that willingly or not you take is meaningful enough. This is another quite common thing to me, very common, you will see. It's called the sunk cost fallacy in the literature, and well, it happens to all of us, right? We invest our time or money or whatever is dear to you in something, and when things go wrong, we have hard time, we are reluctant to abandon the strategy that is bad. We know it's bad, we know we should give up, but we invested so much on it that we cannot, okay? And in economics, this happens in many situations. You have bought stocks and you have bet on it, on that particular stock, but then you are losing money, and then you rationally know that you should sell that stock before you lose even more money, but at that point you hold the stock because of the sunk cost fallacy. And companies found filing project, they start at some point what they call the death march. They know that they are going nowhere, but they invested so much in a project that they cannot take back. And in this way, they develop product with very low or no customers' interest at all, or they pour money into stuff, or for instance, in an ad campaign that is not performing as expected. And they cannot stop this thing, because at that point, they have put so much money in this thing that stopping it will be admitting that you have made a mistake. But the sooner you admit you have made a mistake, the less this thing will affect you, the less money you will lose in this case. But for us as a developer, probably our most important asset is time, right? So it's not really sunk cost fallacy, but to me it's sunk time fallacy. And I don't know if you ever find yourself in a similar situation like this, but you do a couple of months of work on a specific, you had a super good idea, or you believe it is, and you spend a couple of months of work on it, and then you write 7,000+ lines of code, and with 18 commits, but people starting challenging you, and you have 272 comments on this thing because people is not happy with it. But at that point, you have invested 2 months on this thing. So at the end of those 2 months, your only reaction is that please merge my shit, because I don't want to admit to myself that I lost 2 months of my working life, okay? So this happens. As you can see, this happens to me. I don't know if it happens to you as well, but I believe so, right? And again, the first way to avoid this problem is that knowing that we all fail, but we need to fail as fast as possible, because this limits the damage. You know, this is like an avalanche, a snowfall. The more you pour effort or money or time into something, the more you are attached to it, and the more you cannot stop it. So the fastest you fail, the fastest you give up, they see that you are failed, the better it is. So, and to do this, of course, use prototypes, and I want to be clear on this. To me, prototypes are things that you do, maybe in Python, and then since they are written in Python, then they throw them away, and then you write properly in Java when you are happy with this. But I wanted to say that prototypes are not something meant to go in production in any way, right? Okay. And then you look for early feedback. And I like test-driven development because it allows me to do dog fooding, right? If you are a sliding door company, but your main entrance is not a sliding door, probably there is something wrong. I mean that if you are designing an API and then you test that API and you find that you are not happy with the verbosity, for instance, of that API, you are not happy with it and you find it while testing it, then if you yourself, you don't like it, how can you expect that your user will like it? So be honest, okay? And don't be attached to your code. If I comment your pull request, I'm commenting your code. No, I'm not judging you as a human being. I'm not commenting your personal lifestyle, right? I'm just saying I don't like this specific line of code. So I know we are all attached to our own code, but this is not the case. So be objective and be prepared to accept constructive critics. This is another thing that is very common, and in my opinion, it is the main cause why all software rot at some point. What happens is that we have a hyperbolic temporal discount. Okay, so meaning that if I tell you, look, I will give $10 today, or I will give you $11 in 1 week, you will take the $10. Or if I tell you I'll give you $10 today or $15 next year, you will take the $10. Why? Because we have this hyperbolic temporal discounting and stuff that will happen far in the future as less value to us. Okay, and of course this also have some a very bad effect in personal but also enterprise decision. On a personal point of view, it happens quite often that you haven't saved enough for your retirement, or you make debts and you pay crazy interest on your credit card because it's something, paying those interests, it's something that you will do in future, right? And then you suffer of this hyperbolic discount effect. Enterprise-wise, company-wise, it happens quite often that they have a short-term vision, and for instance, they underinvest in research and development because notoriously this is something that costs you money now, and you will eventually see the effect in future. So this is why they underinvest in it, especially in Europe. I don't know why, but this is what happens. And of course, we see a lot of instances of this temporal discounting effect in our day-by-day job. So we skip refactoring because we don't have time, and for the same reason, we don't write tests. We do the quick and dirty architecture. We don't do documentation, right? Not to speak about security. We delay migration and tools update just because we value much more what happens now than what will happen next week or next month. And again, I believe this is the biggest cause of the technical debt, and ultimately is the biggest reason why all software rots. And the fact is that there are studies that demonstrated that, yes, we have this, in our industry, we have this ship now, fix later culture, but fix later, it means that the latest we fix, the later we fix, the more it will cost, okay? So the cost of fixing stuff that you are doing now will exponentially grow in the future. And so we need also to mitigate this problem. We also need to take into account this future cost now. So the way to mitigate this problem is to make this cost visible right now, okay? Try to quantify your technical debt in a way or another. Try to dedicate fixed portion of your working week to fix bug, to write tests, to write documentation, in essence, to fill this technical debt gap, okay? And even here, feedback is the greatest thing, so use shorter feedback loops. That's another quite very common thing in our field. So we took lots of decisions, as I said, but all these decisions, the biggest part of this decision are just habits-driven decisions, meaning that we decide to do something now because we did exactly the same thing yesterday. So we stick with, economic-wise, we stick with the same providers, even if we know that we could do better, or we'll buy always the same brands of always the same kind of food, let's say. And this industry-wise, we continue to produce something even if we could do better. And at the end of the day, this is also the root cause of procrastination. And in literature, this is called the Semmelweis. It is attachment to habits at all cost, and reject the evidence that we could do better by changing even small things. Is called the Semmelweis effect. Anybody knows who Ignaz Semmelweis was? He was a doctor working in the biggest hospital of Vienna in the first half of the 1800s. And in that days, there was a very huge problem that was the fatality rate of pregnant women while giving birth, immediately after giving birth. And they had a name for this problem. They started calling it puerperal fever or childbed fever, meaning that it's a bacterial infection that for some reason attacked women immediately after giving birth. And in the section of the hospital directed by Semmelweis, there was an extremely high fatality rate of this kind. Okay, and he found that the main problem who caused this is that the delivery room was next door to the obituary. So doctor normally did an autopsy and then they go directly to the delivery room without washing their hands. So they asked his doctors, well, he tried to impose to the doctors to wash their hands before going from the obituary to the delivery room, of course. And they all opposed to this. They all opposed to this, first because it was not their habits, but also because another effect that is also, I believe, common in our industry. They are the doctors, you know, so they are there to save people. They couldn't accept that their action could negatively affect the life of the patient, because they are the doctor. They know how to do stuff. They are there to save life, not to kill a pregnant woman, right? So that's why they refused this. And I believe probably this happens also in our cases. So there's a back in production at some point, and it's probably the new code written by the architect, but I'm the architect. I'm here since 15 years, right? How can I be at fault at this? So this happens also in our industry, I think. And we have lots, of course, of habits-driven decisions. So we are familiar with an outdated frameworks, and we keep using it even if we know that there could be better. We copy-paste the same code from a project to another without taking count of the different needs, the different architecture. We continue to homegrown our tools instead of using some industry standard. There is a well-known library to achieve a given task, but we have our own library made by our colleague who retired 5 years ago, so nobody has idea how to improve fix that library, but we keep using it. And we, in general, maintain outdated dependencies for years. And honestly, we're still using Java 8 in production, right? So we are very attached to our habits. And the way to improve for this is to make some of these habits to work in our favor. So yeah, I listed a few suggestions here, but probably what I believe is the most important one is the one that say turn incident into habit-breaking situation. Okay, you had a problem, everybody had a problem, everybody makes mistakes, and everybody can have incidents, but at least let's try to learn from our mistake. Let's try to say, okay, this mistake has been caused by the fact that we do something in a wrong way, and we do that thing in a wrong way since 10 years, but this is not a good enough reason to do this. So let's try to break this habit, because at least now we learned the lesson in the hardest possible way. We had an incident, but let's try to adapt. Let's try to change. And okay, and here, yeah, I'm also giving other suggestions. But you know, they are all related with the former topics, and there are quite common things like the last two. The last two probably are a good way of solve many of these problems. Rotate roles and responsibility in your team, and document and revisit often your decision. Another important and interesting bias, it was called in the literature the framing effect. And the framing effect is the fact that people take different decisions on the very same thing based on how that thing is framed. The cause of the framing effect is our loss aversion. So there are studies that say that if we gain 100 euros or dollars, we are happy, but if we lose the same amount of money, we are 2 or 3 times more sadder than how much we are happy when we gain the same amount of money, right? So it happens that you can frame the same thing in 2 different ways, in a gain way or in a loss way, in a loss frame. So you can say, you can sell a promotion, say, look, you are saving $20 and this is the gain frame, or you may lose $20 if you don't take this promotion, and this is the loss frame. And this has totally different effect on your decision, okay? And marketing people plays a lot of this, okay? It sounds totally different if I tell you this thing costs you just $1 a day, or if I say this thing costs you $365 a year. So it's exactly the same thing, but framed in a way, in a gain or loss way. And naturally, we may have the same effect also in our day-by-day work. So we may say, if we fix this bug, our system will be the 10% more stable. But I can frame this thing also in a lossy way. So I can say, not fixing this bug, risking 1 in 10 users to experience a crash, which is once again, exactly the same thing, but framed in a different way. And since it has been framed in a different way, it has a different effect on our brain, and it forces us to take decisions in a different way. So here what we can do is just reframing, use a consistent framing, okay? If we compare 2 decisions and one is formulated in a gain frame and the other in the loss frame, you are not comparing apple to apple. And this leads you to take the wrong decision just because of how the possibility have been framed. So try to be consistent, try to always I suggest to always use the gain frame to describe a situation, and then you can compare them. Okay, so conclusion. I mean, I believe that I hope that many of you can recognize this bias, these bad effects that I listed today. And I want to be clear, these are, let's say, bugs of our brain, but those behaviors are there for a very, very good reason. Let's take the patternicity, for example. Why we are our brain forced us to find pattern even when there is nothing to recognize. You are a caveman and you are in the forest and you see a shadow, and that shadow may or may not be a tiger. But your brain forces you to recognize a pattern, to recognize the tiger and fly away. And this at time was a evolutionary advantage, okay? Because if the shadow was just a simple shadow, you have wasted a run. But if it was a tiger and you didn't recognize the tiger and didn't run away, then you are dead, right? So probably if you want to choose between recognizing a false pattern and not recognizing a true one, maybe you want to be biased on the first instance. So again, all these things, we do this thing for a good reason. Our brain is wired in this way for a very, very good reason. And I said this a few times during this presentation, but to me the best way to mitigate this problem is leverage your teammate, your team working, use the different skill set of our teammates, rotate responsibilities and roles, and this is important, right? Listen really with the purpose of listening. Often what we do, and I do this myself, I listen just not to listen, but when I'm listening to you, in reality, I'm just taking a pause, thinking myself what will be the best way to reply to what you are saying. But I'm more thinking myself to my next reply than trying to understanding what you are saying. And this is the cause of many misunderstandings. Okay, so I said this lots of time: measure, always measure, never stop learning, and of course try to enlarge your professional toolbox, because more things you know, the less you are biased, because you find alternative, you do lateral thinking, you have different possibility, okay? So enlarge your professional toolbox as much as possible. And I say professional, so for instance, Node.js or even Python are not part, of course, of this professional toolbox, right? And I'm saying this just to say that, yeah, I'm a human, I'm biased as well, right? So we are all on the same boat. So thank you. And yeah, I have 4 more minutes, so let me use it for a bonus thing. Anybody knows what is a Keynesian beauty contest? This is a theory made by Keynes like 100 years ago. Okay, the Keynesian beauty context is a special beauty context where you are not supposed to judge, to say who is the most beautiful girl for you, for your opinion, but you are supposed to say who the majority believes that will be the most beautiful girl, okay? And this, of course, activates a loop, because you start trying to figure out what is your most beautiful girl, and you try to do the same, and I try to do this thing 2 steps forward, meaning that I try to figure out what you think that or what I'm thinking. So you find this, you generate this loop, okay? This self-reinforcing cycle, and this is often the cause of the bubbles in finance, in stocks, for instance, right? Because we believe that you want to buy tulipan, and I want to buy tulipan as well, and then the tulipan bubble grows up, right? And we are, of course, in this same situation. So everybody at some point decided that Python is the only thing to do AI, and for this reason, this thing self-feeded itself, and this thing grows and grows. So it's a network effect where we feed each other with false believing, and we need to break this circle. And yeah, of course, we can all agree, I think, that agentic AI won the Keynesian beauty contest 2025 because I'm doing LangChain4j and you are doing, I don't know, Spring AI or Embubble or whatever it is. And if you don't do this, you are out of market. So this thing clearly won the Keynesian beauty contest this year. I wonder if it's here to stay, and probably next year we will have a different winner, but at this point I really cannot guess what will be. And that's all I have, really. Thank you.